No, I'm recording now. So partial series. Anyway, it's all kind of anecdotal things that you discover when people are watching you on YouTube and stuff like that. Anyway, consider the sequence. A generic sequence, let's say, collection of A sub n, like so, and then we define partial sum in the following manner. We're going to define S sub 1 will be simply the first term of the sequence, A sub 1. S sub 2 will be the sum of the first two terms, A sub 1 plus A sub 2. A sub 3 will be, of course, the sum of the first three terms, and so on. Okay? And now the general term, so we continue like that, and we're going to say that in general, we can stop at one point and say S sub n, the general term, will be the sum A sub 1 plus A sub 2 plus A sub 3 plus dot dot dot, and we stop at n. So we have the last term will be A sub n, and using the sigma notation, it will be the sum as I is the counter, the index, goes from 1 to n of A sub I, like so. So this is a definition, really, of a sum of a series. We have a series like that, and if you look at this S1, S2, S3, all the way to S sub n, we created a new sequence. Okay, so we can write that the partial sums form a new sequence. And we'll call this sequence S sub n, the set of F sub n. So we'll put it in curly brackets, like so. Now, this particular sequence may or may not be may or may not have a limit. Okay. In other words, we are looking in the long run. We're looking at divergence and convergence. So S sub n, the set or the sequence S sub n, may or may not have a limit. What else we can say about that? We're going to also consider the following, that we're going to say that if the limit of this S sub n, so now we are looking at the last term right here in the sequence. So we're looking at the sum or the series S sub n. When n goes to infinity, if this thing equal S, which if this limit exists as a finite number, in other words, it doesn't blow up, it doesn't go to infinity or negative infinity. So the key word is a finite number. Then we're going to say that S, which is the value of this limit, is simply the sigma of what we saw here. So it will be the sigma of A sub n, the sum of the sequence or the series. Okay? So actually we're going to write it as it's the sum of the infinite series. Why infinite? Because we let n goes to infinity. Remember, in this chapter, we deal with infinite sequences an infinite series. So here we can say n goes from 1 to infinity. Just we omit normally in this context, whenever we want to say that we have infinite series, we omit 1 to infinity. We know it from the context. The last thing is just a word about convergence and divergence. Okay, so we'll write the following. We have a convergent series if that sigma that I wrote here above, so this is a repetition of what the if and then statement. If the sum, the sigma n goes from 1 to infinity of a sub n equal s. Again, s is a finite number. We're going to say that then the series is convergent, and we're going to say that the series is divergent otherwise.